we have discussed the criteria for running a regression algorithm or a classification algorithm. When to run a regression algorithm, when to run a classification algorithm, it all depends on the structure of the dependent variable which is there in your data. The dependent variable will be defined in the problem statement. Most of the times, the problem statement will have the dependent variable predefined. When you get the mandate from your client, you will get the dependent variable. And the structure of the dependent variable will decide to run a regression algorithm or a classification algorithm. And in the previous session, we dealt with the dependent variable which was numerical, continuous, closer to normal distribution with minimum outliers and no missing values. We have built a regression model, the basic model, which is your multiple linear regression. Now we have been also working on the second data set, HR analytics. In HR analytics, the dependent variable denoted by Y is underscore promoted, which is in the form of 0 and 1, which is nothing but no and yes. No is 0, yes is 1. So the dependent variable is non-numeric and binary. In this case, Y is non-numeric and binary. Binary means two categories. You have to make a binary decision, yes or no. Now, this is the perfect case for classification models. This is the perfect case for the classification models. And the fundamental model in classification is binary logistic regression. Binary logistic regression explains the relationship between a binary dependent variable, and multiple independent variables that can be both numerical and non-numerical. That can be both numerical and non-numerical also. So binary logistic regression explains the relationship. What relationship? Linear relationship. Sorry, I forgot the word linear here. Between a binary dependent variable and that can be both numerical and non-numerical. So binary logistic regression. The binary logistic regression is an equation. P is equal to P to the power of x1, beta 2, x2, divided by 1 plus of this is the equation of binary logistic regression. Similar to multiple linear regression, binary logistic regression is also an equation. Binary logistic regression is also an equation. Wait, let the topic be complete. exp to the power of 1 plus 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 B0 plus B1 x1 plus B2 x2 plus B3 x3 Bn xn. The denominator is 1 plus the same equation. Now, if you look at the components of the equation, P here represents to predicted probability. P represents the predicted probability that lies between 0 and 1. P is the predicted probability. So when you solve the equation here, you will get predicted probability. When you solve the regression equation, you get a predicted value. Here it is predicted probability that lies between 0 and 1. EXP is nothing but exponential. What is the value of exponential? 2.718 something. B0 is your intercept or constant. B1, B2, B3 till Bn, we call them as coefficients x1, x2, x3 till xn, we call them as independent variables. So this is the structure here. Once you solve for the coefficients and the intercept, you will create an equation like how we created in the multiple linear regression. Similar type of equation will be created. That type of equation will be created. And then we'll use that equation to predict the probability. We predict the probability. We will not predict the value. So the probability is one of the most important part of your logistic regression. Okay, and the probability lies between 0 and 1. Now, the classification rule. The classification rule is probability greater than equal to is classified as 1. Probability less than equal to 0.50. Sorry, I forgot the value. 0.50 will be classified as 0. So the classification rule for binary logistic regression is, if the probability is greater than equal to 0.50 will be classified as 1. Probability less than 0.50 will be classified as 0. Got it? Now, assumptions of binary logistic regression. The assumptions of binary logistic regression. Y must be non-numeric and binary. Y must be non-numeric and binary. What is Y? Dependent variable. X's can be both numerical and non-numerical. Access can be numerical and non-numerical. Linearity. There must be a logical linear relationship between Y and X's. no multicollinearity. No multicollinearity. There should not be any multicollinearity, the same assumption which we have in our regression. Sample size must be minimum 50 observations per variable. Sample size must be minimum 50 observations per variable. Now, the interpretation of output. The interpretation of output in Python. The first parameter is accuracy calculated from confusion matrix. Accuracy calculated from the confusion matrix. The second thing which we will get is the intercept plus the coefficients. So you will get only these two outputs in Python. Now, for all classification problems, confusion matrix. For classification models, confusion matrix is the primary diagnostic, which is a 2x2 matrix of the actual class and predicted class. So confusion matrix is a 2x2 matrix for binary classification. For a multinomial classification, it is an n by n matrix. For a multinomial, n by n. Whatever levels are there, it will be there. For a binary class, it is a 2x2 matrix of actual and predicted class. So predicted positive and negative, predicted positive and negative. This is actual, positive and negative. All right. Now, actually, the data set is positive, predicted is also positive. Is it correct classification? With the correct classification, we call it as true positive. Actually, the data set is positive, but we have predicted it as negative. This we call it as false negative. We are predicting negative false. Actually negative, but model predicted it as positive. This is wrong, false, positive. Actually negative, the predicted negative is true, negative. Let's start classification. So diagonally, these two are your correct classifications. Diagonally, these two are your correct classifications. Okay. Now this is called DP. This is called FN. This is called FP. This is called PN. The primary metric is accuracy PP plus PN divided by PP plus FN plus FP plus PN. Accuracy is the primary metric which must be between 0.70 to 0.95. The score function in regression gives you R square. The score function in classification will give you accuracy. Next is sensitivity, also called as recall, which is true positive divided by true positive plus false negative. This also should be above 0.70. Specificity. Specificity is equal to true negative divided by false positive plus true negative. Precision. PP by PP plus FP. F1 score 2 into precision into recall divided by precision plus recall. So these are the metrics which are very important in conclusion metric. The primary metric is accuracy. The other metrics, sensitivity, recall, and F1 score are very important when your data is imbalanced. Imbalance means when there is a majority class and a minority class in a dependent variable, then the metrics like sensitivity, precision, F1 score becomes a critical matrix. Precision into recall by precision plus recall. Yeah, 2 into. This is the formula. So these are all the metrics. False negative is the type 2 error. False positive is type 1 error. Type 2 error is dangerous than type 1 error. Type 2 error means hanging an innocent man. Or rejecting the null hypothesis when actually it is true. Type 2 error means hanging an innocent man. Or rejecting a null hypothesis which is actually true. Type 1 is letting go of a criminal. We know he is a criminal, but he is let go. He is not punished. That is called type 1. Failing to reject the null hypothesis when it is wrong. Okay? Failing to reject the null hypothesis when it is wrong. So these are the type 1 and type 2 errors. Remember type 2 error. Type 2 error is the most common, which is hanging an innocent man. Type 2 error is hanging an innocent man, which is rejecting the null hypothesis when actually it is true. Got it, all of you? So confusion matrix is the most important for all classification problems. Binary logistic regression is also called as sigmoid equation. When we do neural networks, we talk about sigmoid activation. So the logistic regression is also called as sigmoid function. 1 by 1 plus e to the power of minus z. So this is sigmoid function 1 by 1 plus e to the power of minus y. Y is your regression equation. By replacing the values in sigmoid log of p by 1 minus p, you will get intercept plus b1 x1 b2 x2 till bk xk. This is the logistic regression equation for logs. And the classification rule. The classification rule is also very important here. So typically, the logistic regression will be an S-shaped distribution. What is the distribution for linear regression? Bell-shaped, bell curve or normal distribution. For logistic regression, it will be typically an S-shaped curve. And the threshold is 0.50. Greater than equal to 0.50 will be 1. Less than 0.50 will be 0. The classification threshold and the classification rule. Based on this S-shaped curve. Based on this S-shaped curve, the probability will be classified into class 0 or class 1. Greater than equal to 0.50 will be 1, less than will be 0. So this is the distribution S-shaped curve for logistic regression, which is also very important for our classification rule. The classification rule is derived from the distribution curve, which is the S-shaped curve. It looks like an S-shaped curve with threshold of 0.50. So it is nothing but logistic regression. You have the logistic regression as e to the power of that, right? If you want to write it into 1 by 1 plus, it will e because that z becomes minus. 1 by 1 plus e to the power of minus z. Now what is the equation e to the power of z divided by 1 plus e to the power of z? You take out e to the power of z, that becomes 1 by 1 plus e to the power of minus z. Got it, all of you? So we have not imported HR test. All of you import HR test is equal to. Earlier we imported HR test. If you have already imported the test file, it's okay. Otherwise, please import the test file. Import the test file also. Okay, all of you imported it. Check the missing values. So we have missing values in previous year rating. We have missing values in education. HR test dot is null dot sum dot sort underscore values ascending is equal to false. So we have similar missing values in both train data and test data. Train data and test data both have missing values in same columns. Done, all of you done with these two steps? Got it, all of you? Train and test has similar columns, missing values. So what we will do? We'll concat them. But before that, we will add the dependent variable. HR test is underscore promoted is equal to test. Add the dependent variable to the test data. The test data does not have the dependent variable. Combined DF is equal to AD dot concat square bracket HR train comma HR test comma axis is equal to 0. 0 means row wise concatenation. So it will first paste all the rows of train data, then below it will paste all the rows of test data. To make sure the number of variables equal, we are adding the dependent variable in the test data and filling up the values with the word test, so that we can use it as a conditional statement later to split the data. Okay. All right. So combine df dot shape. 78,298 observations, 14 variables. 78,298 observations, 14 variables. So combine df dot education dot value underscore counts drop NA is equal to false. So we have 3,443 missing values in the variable education. In the variable education, we have 3,443 missing values. Now, by adding those 343 to bachelor's 52,000, will that make a difference? No, because already there is a big difference between bachelor's and masters. 30,000 is the difference between bachelor's and masters. By adding these 3,000 missing values as bachelor's, it will not make any difference. So we will fill the missing value with the word bachelor's. We will fill the missing value with the word bachelor's. Already it is distorted by 30,000. What can we do? Already it is distorted. So what can we do? By adding 3,000 to the already distorted thing, and most of the organizations will have bachelors more than postgraduates. Look, any organization, postgraduates combine less than the bachelors. So we will fill up the missing value. So combine df dot education is equal to combine df dot education dot fill NA. Now fill NA will fill the values automatically. So you have two options. You can give the filling value automatically, or you can write. Sometimes you'll have larger tables, you can't see it so clearly. So what we will do is, combine df dot education dot value underscore counts dot idx max. IDX max. So first we will do the frequency table like what it is in the top. Finds the maximum value 52,247. Index of that maximum value. Index of the maximum value means the name before that maximum value. Index. IDX means index. So it will automatically impute the missing value with the maximum thing. So you'll see here bachelor's is 52,247. Now, if I run this statement again, bachelor's become 55,690. You can fill in a double quotes and you copy paste the bachelor's there. You can also do that. You can also do the simplistic way in fill in a. You can also do like this. You can also do like this also. But this is not preferable because this is a small table you can identify. In reality, you will see large scale frequency tables with larger values. You have to sort it, then find the value and all those things, right? So instead of that, if you use this IDX max, it automatically does the frequency table and automatically includes the index of the maximum value. Index means class of the maximum value. Here the maximum value is 52,000 something and its index is bachelor's. You can type this command in straight line. Fill in a combined here dot value counts dot IDX max. First it will do the frequency table, identifies the maximum numeric value, corresponding index value, corresponding index of the maximum value. IDX max means index of the maximum value. It automatically does. Here we will keep it as missing only. When you that's what we did in big word sales, right? No. When we are not sure, we will fill in it with the word missing. When you are not sure, so what to do with the data, I told you, use the word missing. In fill in a brackets, double quotes missing or not available. Whatever name you want to give, we can, but don't give none. Don't give none, because none is an inherent syntax. So either not available or missing value. Don't give NA also. NA is also syntax here. Missing, not available, not found. Like that you can give a word. If you are confused. Here is there a confusion? No. Because already there is a big difference. 31,000 difference. Adding 3,000, 10% to that, will it make any difference? It doesn't make any difference. That is what we are doing here. So people have done this, do the value counts of previous year rating, the other missing values. Do the missing values for, do the frequency counts of previous year rating. The other variable that has missing values is previous year rating. So combined here dot PRE and then press the tab, it will automatically fill it. Dot value counts. Drop NA is equal to false. The other variable that has missing values is combined here dot previous year rating dot value underscore counts drop NA is equal to false. Remember, rating scales cannot be treated as numbers. Rating scales have to be treated as categories. So what should we do with the missing values here? How many missing values are there? 5,936. Already there is a big difference between 3 rating and 5 rating. So we will fill the missing value with the 3 rating. Obvious, right? So by adding this 5,000 to that will not make any difference. So combined year dot previous year rating is equal to combined year dot previous year rating dot fill NA open bracket combined year dot previous year rating dot value underscore counts brackets dot idx max brackets idx max brackets. Same command what we have done. Yes, I'll run the command again. Now you see there are no missing values. In the next case study, we'll incorporate this argument into a loop. Here we have only two variables. We are manually doing it. But when you have 30, 40 variables and when you are doing it, you have to run a loop. You can't create 30 individual steps for doing it. No. We will be running a loop on all the variables and then we will include with the loop. Okay, so you are saying minimum 5956. Now can you inflate the minimum rating? See, lowest rating is 1, highest rating is 5. Right? So if you are inflating the minimum rating or 1 rating, that means your organization is performing badly, right? What we are doing is we are adding to the average rating or median rating. What is the median rating here? 3. 3 is the median rating, right? So you will be on safe side. Okay, organization has an average performance. If you add them to 1 rating, then it becomes organization has a very bad performance because close to 14,000 employees are not performing well. If you add it to 5, that means you are saying your organization has 21,000 high performers, everybody will demand promotions. Again, that's a problem. So we keep them in the median. What is median? 3. So you are in safe side position. Because everybody, most of them will be in 3 rating only, right? Median rating only, most of the population will be there in the median rating only in organizations. Now, if you are working as managers, you know this problem. Out of 10 people, you can only promote 1 person. You can give 2 persons 4 rating. And you should give at least 1 bad rating. And rest of all, you should give them as average rating. This is the thumb rule we follow. 1, 2, whatever is left out, and the bottom is 1 bad rating. Some organizations also want 2 rating also. 1 2 rating and 1 bad rating. 1 rating. And rest of all should be in 3. There should be only 1 5 rating. That guy will be promoted. 4 rating, 2 guys will get considered for promotion in the next cycle. And rest of all will be given average ratings. This is how the evaluation process happens in teams. Same thing will be extrapolated for larger teams. Basically, 10% of the organization will only be promoted. 10% of the total employees will only get promoted. That is the standard thumb rule followed in Indian organizations. In fact, they want to keep it in single digits. Some companies keep it at 8%, 9% only. Okay? All of you got done with missing values? All right. Now, combine DF dot columns. Combine DF dot columns. Now, from these columns, we need to separate object columns. Object calls is equal to combine DF double square brackets Department is object, right? Region is object, education is object, gender is object, recruitment channel is also object. Then, comma, number of trainings, age is numerical, previous year rating. Rating scales are categorical in nature. So previous year rating will be object. KPIs met. KPIs met. And awards won are in 0 and 1. Binary encoding. So we will keep them as object columns. So these are the variables that fall under object columns. Similarly, numeric columns. Combine DF, double square bracket, number of trainings, age, comma, average training score, length of service. Length of service is a numeric variable. Average training score and is promoted, we give them as numeric, but is promoted, we will change it back to object later. So we have split our data into numeric columns and object columns. Okay. Copy paste from the columns output. Please don't type. Copy paste from the columns output. Okay. Now, why we have split them into object and numeric for label encoding or dummy variable encoding? This is your object columns. They are in text. Object calls are in text. Now we have to convert them into dummy variable and codes. We have to convert them into dummy variable and codes. For that, we will use from sklearn dot preprocessing import label encoder. LE is equal to label encoder brackets Now I'll create a new data frame called object calls dummy. Object calls dummy is equal to object calls dot apply le dot with underscore transform. Now, if you put object calls dummy dot head, you will see what is the change. Okay, all of you got this? Now, if you print the head of the dummy, you will be seeing that it is all numbers. And it did not have new columns, right? In the same column, it has given the numbers. Now, combine df clean is equal to pd dot concat square bracket numeric calls comma object calls dummy comma axis is equal to 1. We are doing column wise concatenation. Column wise concatenation. First pasting all the numeric calls, and then we will paste all the object calls dummy. Didn't give brackets next to label and quarter. Check it. LA is equal to level equal to, did you give brackets there? Now we will split the data back to train and test. HR train DF is equal to combined DF clean square bracket combined DF clean dot is underscore promoted not equal to test. HR test DF is equal to combined DF clean square bracket combined DF clean dot is underscore promoted double equals to test. HR test DF is equal to HR test DF dot drop is underscore promoted comma axis is equal to 1. We are dropping the dependent variable which we have created earlier for concatenating the data fields. Okay, all of you are done till this point. Did you give brackets to next level and quarter? Done, all of you done? Okay. Now, we have our data cleaned up. Now we'll split the data into y is equal to HR train df dot is underscore promoted. Capital X is equal to HR train df dot drop is underscore promoted, comma, axis is equal to 1. Y is equal to elite dot fit underscore transform y. We have label encoded the y. From sklearn dot linear underscore model import logistic regression. Logit is equal to logistic regression null braces. Logit model is equal to logit dot fit x comma y. Oh, iterations are not enough. So we give max underscore iter is equal to 2000. Logit model dot score x comma y. Accuracy of 91.72% accuracy. Just split the data into train and test. So logit model is equal to logit dot fit x comma y. Logit model dot score x comma y. Yeah. dot fit, fitting the model, dot score, here you will get accuracy. In the back end, it will do confusion matrix and it is giving you the accuracy score. Because I got an iterations error. It said iterations are not enough. So I made max iterations as 2000. By default is 200. So it threw up a warning saying that iterations are not enough. So I will increase iterations to 2000. Okay. Logic predict. Logic predict is equal to logic model dot predict of x. Logic model dot predict of x. For seeing the PD dot cross tab y comma logic predict. We'll get the confusion matrix. Calculate accuracy and see whether you got the same accuracy or not. Calculate the accuracy from the confusion matrix and see if you got the same or not. So if I just scroll down, so brackets 49,948 plus 323 divided by 49,948 plus 192 plus 4345 plus 323. You got the same accuracy from the confusion matrix what you have got earlier. Got the same accuracy. The diamond are correct predictions. Because 0 is negative, 1 is positive. These are just promoted, 0 is what? Negative, right? is underscore promoted 1, which is yes, is positive. So the matrix reverses. There, positive first, negative second. So you have to take it as negative and positive. Here 0 is negative. So the topmost is true negative. So 49,948 is true negative. 192 is false positive. 4,345 is false negative. 0 is negative here. True negative. False positive. False negative. And true positive. Okay, that is random, no problem. Because random state is there. See, this should be same. If this might change because of the random running, you might run it 2 times or 3 times. This marginal change is there. It is same. So this is false negative. So this algorithm is predicting false negative score. That is the problem. Not only that, there is a big problem here, which we will discuss in later stages. From sklearn dot metrics import classification report. Print classification report y comma logic predict. See, there are major imbalance. This is a classic example of imbalanced data. Because we have 50,140 zeros, 4,680, 68 ones. Overall accuracy is 92%. But look at the predictive accuracy of minority class. All these metrics should be above 0.70. All these metrics precision for minority class is below 0.00. This is even worse. Recall. What is recall? Sensitivity. True positive by true positive plus false negative. This is the problem. This is imbalanced data. See, there are many nodes, zeros, and only few ones. When you have imbalanced data, we can't go with accuracy only. You have to print the classification report, check the minority class precision, recall, and upfront score. This is a failed model. Despite getting 92% accuracy, which is good. But because of the minority class prediction problem, it is predicting a lot of false negatives. For imbalanced data, this is imbalanced data. Balanced data means not equal, exactly equal. 60-40 is a balanced data. 52-48% balanced data. 65-35 also we will consider as balanced data. But 70-30, 80-20, 90-10, purely imbalanced data. We have other techniques called balancing techniques. We will discuss later when we go into that advanced thing. So for this problem, as of now, look at the accuracy. Accuracy is 92%. The accuracy is given in the classification report as 92%. Imbalanced data immune techniques might be gradient boosting machine. So it all depends on data. For some data, random forest works. For some data, boosting machines. Some data, neural networks. Neural networks are supposed to be robust. Got it, all of you? Classification report. Now, one more metric which is considered is from sklearn dot metrics import plot underscore ROC curve. Plot underscore ROC underscore curve logic comma x comma y. So area under the curve is 0.81. Area under receivers operating curve, also called as AUC, is how much it's there in the bracket in the bottom of the graph. 0.81. This is also good. Anything above 0.50 for AUC is good. What is all of you? So AUC is also one of the metric which we need to report for classification. Accuracy, AUC, if it is an imbalanced data, we have to print the classification report. When minority class is 1 here, 4,668. That is having very bad prediction. The prediction of minority class is very, very bad. So logistic regression is affected by imbalanced data. So this is the method for running logistic regression in Python. Okay, all of you got this? So logistic regression is a primary classification algorithm which we need to use on binary data. There is multinomial logistic regression also. You can use it for multinomial also. But you have to give the argument multi underscore class is equal to multinomial. We will deal with multinomial data set. That time we will discuss the multinomial algorithm. Yeah, I have sent you an Excel sheet. Download it.